Okay, so we're going to continue where we left off. So I'm going to do the fifth problem here. So what do I have there for the fifth? I would say the first thing you really want to do is clean this up a little bit. So let's clean up. And let's say, let's make this, use your exponent rules. This is x to the 8 dx. And when I take that antiderivative, it's going to end up being, write down your x, take your 8 and add 1 to it, divide by that same power, and add c. Done. Okay, here you have your e. Remember code for e. So write down exactly what you see, and then you're going to divide by what? By the coefficient right here, and then add your c. Done. Got two more on this page. Okay, look carefully here. We kind of get in the mode of looking at powers only and forget the variables. This is just a constant. Okay, so that's just a constant. If that's just a constant, then isn't the antiderivative just 10 squared x plus c? And you can certainly make that 100. All right, so now we have three integrations. We're going to do it all at once and move from the left to the right. The first one is just 4x. So that means we're going to take the x, raise it to the second power, and divide by the same. This, be careful, that is just a constant. Again, be on the lookout for e's. Constant. Okay, so no, be on the lookout for e's and x's. There's no x. So we're going to handle it as a constant. We're just going to tack on the x, and we're done with it. Now, this is a natural log situation. So that's going to be 20, that k comes along for the ride, natural log of x, and then don't forget the c. Okay, so we can clean this up a little bit. We don't need to have a fraction there. 2x squared plus 7ex plus 20 natural log of x plus c. And we are done with the initial examples. Okay, let's see what else we have. So now we're going to look and we're going to say, I need to do definite integrals. How is that different than indefinite? So definite integrals are going to have endpoints. So that is the big difference. Okay, and we're also going to work on the fundamental theorem of calculus. So this material here is going to focus on definite integrals. Got the endpoints. The previous section, this should be section, focused on indefinite. So examples working with definite integrals. First, calculate the following indefinite integral. Okay, so we're going to practice this one more time. So that's going to equal x squared over 2 plus 0.5x. And then if it's indefinite, I have to add the plus c. Okay, what if it's definite? Oh, look, here come my a and my b of my endpoints. So look what's going to happen. I'm going to have the exact same answer in terms of the integration. But now what's going to happen is I'm going to draw a vertical line right here. The top of the vertical line, I'm going to put the 1. At the bottom of the vertical line, I'm going to put the 0. Then I'm going to do the following math. I'm going to plug in the 1 wherever I have an x. So the first piece becomes 1 squared, which is just 1, plus 0.5 times 1, which doesn't change either. So I have that, those two terms, and now I'm going to subtract that from plugging the 0 in. If I plug in a 0 in the x squared, that's going to be a 0. If I plug in a 0 in the x attached to the 0.5, that'll be a 0. So my end result is going to be 1/2 plus 0.5. And 0.5 is just 1/2. So 1/2 plus 1/2 is 1. Okay? So we're kind of doing what we did with Riemann sums to find the answer, but we're doing it using the integration tools we've just gone over. Okay, so how can we relate this? Well, isn't this, that's x plus 0.5x? That's just a line. Okay, so this is just a line. This is just a line. So therefore, this is my little f of x, right? And that was x plus 0.5x. And aren't I trying to calculate the area under the curve? So I am running from 0 all the way to 1. So I'm coming across here. Once I get here, I'm going to drop this down. So what do I have? So I'm going to figure out what this is. So I want the area under the curve from these points. So don't I have a rectangle? So here's my rectangle. And that rectangle is 0.5, because this is 0.5, times 1, which equals an area of 0.5. Then I have my little triangle. Well, my height of the triangle is going to be from 0.5 to 1.5. So this height is going to be 1. And the width is also going to be 1. So the area of a triangle, so this is a triangle, is going to be 1/2 base, which is 1, times height, which is 1, which is just 1/2. So I'm going to add these two areas together. They're both equivalent to 1/2. When I add them together, don't I get 1? So that's the area of the triangle plus the rectangle equals 1, which matches what I have up here. So this would have been a Riemann sum approach down here in the graph, and this is an integration approach using the formula. But either way, I'm going to get the exact same answer. Okay, so that's the connection with Riemann sums. Okay, so let's keep going. Consider areas above and below the x-axis. Okay, previously we only talked about areas that were above. Okay, so we were always looking at above. But what if the function is continuous on this interval from a to b? So look at the picture. Here's my a, here's my b. So it's equal to the area above the x-axis bounded by the graph from x equals a to x equals b, minus the area below. Oh, how come it's minus? Because these values will be positive and these values will be negative. So if you get the absolute value, you're going to be subtracting the areas of A and C summed from the areas of B and D summed. Okay, so this is what we're doing. Area B plus D minus the area A plus C. That's what we're going to get. So we will find that the area above the x-axis has positive values, and the area below the x-axis is going to have negative values as we work through our problems. So let's work on that a little bit. Okay, so next page, we are looking at calculating the following definite integral. So it's going from -1 to 1. Here's my x dx. So using my rules of integration, I'm going to get x squared over 2. I'm then going to do that vertical line with a 1 up top and a -1. And then I'm going to do the math. So that's going to be x squared. If 1 is x squared, that's going to be 1/2 minus, if -1 is squared, it's still positive 1. So 1/2 minus 1/2 is going to be 0. How come? Well, look what we're doing. We are running from 1, which is -1 right here, to 1. Guess what? These areas are both the same. But what do we know? This is going to be a positive. This will be a negative. And when I see it visually, I can see they cancel. But when I do it mathematically, the result is they cancel and I get a 0. All right? So we have been working with the fundamental theorem of calculus without stating that. So let's see if we can figure all of this out. So first off, I want you to know that on a graphing calculator, you can put this in. So you're going to have to look at your graphing calculator. If you turn it on and you go to math and then you go down to 9, you're going to see, let me go back, and you press that key at 9, so I'm going math 9. This is what shows up in my calculator. I have a box, I have a box, I have this, and I have D, and I have a box. So that means that if I plug in exactly what I see and hit enter, I'm going to get an answer. So again, I went to math 9, and math 9, when I went to that, it said down FN integration, function integration, and it has this. When I press the key, I get this. Okay, so we're going to do it by hand, but I'm going to check it with the calculator. So look what's going to happen. This is going to give me 3x, raise that to the 1/3 plus 3/3, which is 4/3, and divide that by 4/3. Okay, so I'm just going to do it just this way first. Then keep going. Minus, this is a constant, so it's just minus x, minus, oh, there's our friend e, so it's e to the 0.5, and that 0.5 is going to be down here as well. And then I don't need a c, right? What I need instead is this, the 1 and the 0. Okay, let's clean this up a little bit. So I have 3x to the 4/3 times, flip it over, 3/4. Okay, minus x minus dividing by 1/2 is the same as multiplying by 2. Okay, and then I'm going to do 1, 0. So let's plug these numbers in. So this top, let me just erase this and make that, well, I'm just going to do this. That's really a 9, right? So I have 9/4. So I have 9/4, 1 to the 4/3 is still 1, minus 1, minus, oh, I'm sorry, I have to have an x here, minus, and that should be an x here, lost my head, minus 2 e to the 0.5. That's the first part. And then minus, now you're going to raise everything to the 0 power. Okay, so what do I know? If I raise x to the 0 power, if I make this a 0, 0 to any power is still going to be 0. So I end up having 0 minus 0, but then look at the last one. That's going to raise e to the 0 power. Anything to the 0 power is 1, so this is just minus 2 times 1, or 2. Okay, so then let's figure out what this is. What if I made my 1 a 4/4? Isn't that going to let me say that this is 5/4 minus 2e to the 0.5, and then minus a minus 2? Okay, so when I do that math, and I put this in my calculator, I should be getting negative 0.047442. And putting it in my calculator here will get me the exact same answer. Okay, so you should try it with the calculator so you can verify it. Okay, so let's do another one. So look over on this one. I'm going to take that anti-differentiation. I'm not going to graph this. And it says give answers in exact form. So this is going to equal x cubed over 3 minus x squared over 2. And you're going to evaluate that from 2 to 0. So 2 to the cubed is 8. So this is 8/3 minus 4 halves. 4 halves are just like 6/3. So you're going to end up getting 2/3. Okay, and you can check this with the calculator by putting this in. And we can talk about that when I see you in person. So next one, this is going to be x squared, and then I'm going to divide it by 2, But before I do that, let me clean this up. Isn't this 3 to the x minus 1/2? Okay, so then let's keep going from looking at that. That's going to be 3, 3 comes along for the ride. Add 2/2. That's going to give you x to the 1/2, and then divide by 1/2. And you're going to evaluate that from 4 to 1. So what do I have? 4 squared is 16, and 16 divided by 2 is 8, minus the square root of 4 is 2. 3 times 2 is 12, and 12 divided by 1/2 is what I want to do. That's going to be 8 minus, that's going to be 6 divided by 1/2, which is 6 times 2. So that's minus 12. That's the first term. So I'm going to take this and then subtract away. Okay, put a 1 in. So square root of 1 is still 1. So that's going to be 3 over 1/2. So let me think about this for a second. So if I plug in a 1, so that's 3 divided by 1/2, which is going to end up being, oh, I'm so sorry, I have to do this one first. Lost my head. So that's going to be 1/2. 1/2 minus, and then 3 divided by 1/2 is just like 3 times 2. So I have that. Okay, so let's clean this up. I have negative 4 minus, what is that going to be? Well, this is 12/2. So 1/2 minus 12/2 gives me a negative 11/2. And now I have this, so let's make this negative 8/2 plus 11/2, and that's going to give me 3/2, which you can check with the calculator. Okay, we've got one more to do. It's actually 2 more to do. Looking at this one, what do I see? So I'm going to say rewrite the integram before you anti-differentiate. Absolutely. So let's get that squared away. So what will I have? I'm going to have this 9/4. This is going to be, so it's going to be x to the 1/2, or to the negative 1/2, sorry, times x minus 3. So isn't that what I have? So I'm going to bring up that x to the 1/2. When I bring it up, it becomes x to the negative 1/2. So let's clean that up. This is 4 and this is 9. And that's going to be x to the 1/2 minus 3 times x to the negative 1/2. dx, okay, that's easier to work with. So that's going to become x to the 1/2, add 2/2, that gives you 3/2, divide by 3/2 or multiply by 2/3, minus 3 comes along, add 2/2, you get another x to the 1/2, and you can divide by 1/2 or you can multiply by 2. So I'm going to put a 2 here, and then I'm going to evaluate that from 9 to 4. So what do I end up having? So let's clean this up a little bit. So this becomes a 6 right here. And so I'm going to just do the math. I'm going to get, when I did it on scrap paper, this is what I got. So I'm going to end up getting 6 2/3. See if you can get that. And then the very last one, you've got to recognize that that is just natural log of x. Done. Evaluate that from 3 to 1. And that's going to be natural log of 3 minus natural log of 1. That goes in your calculator, and we have that final answer. And we are done. So we can go over this in class, but I hope this gives you an idea of how we're doing integration following the rules.